Okay, let's start our meeting today for the subject of productivity engineering. And our topics for today is we're going to continue what we discussed last week. If last week we talked about the general model for productivity measurement, but now we're going to talk about the some or several productivity measurement model that proposed by different, could be different people or different organization. Yeah, first we're going to start with total productivity model that is proposed by Sumanth. Yeah, the total productivity model developed by Sumanth is the extension of earlier model. So in the productivity model, yeah, considered by proposed by Suman, it has about 5 different items as the input. So those items are humans or employees, and then material, and then energy, capital, and other expenses. Yeah. And the formula for calculating the total productivity, especially the model that developed by Sumanth, is you see there. So this one is equal. So total productivity is total tangible output per total tangible input. Yeah. One thing that differentiates between the model developed by Sumanth with the other model is that in the Sumanth's model, is clearly talk about tangible input and tangible output, and tangible input. Yeah. So the Sumanth model is only consider output and input that are tangible. So intangible output or intangible input in this case will not be considered. Yeah. So what are the tangible output and what are the tangible inputs? The tangible output may consist of, first, value of finished good produce, yeah, value of the finished good produce. So we can calculate it by counting or determining how many finished good produce times the price of the finished goods, each unit measurement. So for example, if a manufacturing company, they can produce, for example, 1,000 units of finished good, yeah, and the price for each unit is $1. So the value of finished good is 1,000 times $1. So it's about $1,000. So the number of finished good produced times the price of the finished good. That's the first one, the value of finished good produced. And then the second one that can be considered as the total tangible output is partial unit produced or work in process. Yeah, partial unit produced or work in process. So work in process is actually unfinished product or unfinished goods. Okay, but according to Suman, this partial unit produce or work in process, it can be considered also as the tangible output. So we can calculate the value of the partial unit produce. The third one is dividend from securities. The fourth one is interest from bonds and also other income. So those are example of tangible output in Suman's model. Yeah, it's not limited to only those 5, but actually every output that is tangible can be considered as the output in Sumanth model. Any output, as long as it's tangible. Intangible will not be considered. Okay, on the other hand, the total tangible inputs, yeah, in the Sumanth model, the first one is value of human inputs. Yeah, the value of human inputs, yeah, or we can say that is similar to employee costs maybe, yeah. And then plus the capital inputs, how much money invested for such process, and then material consumed plus energy input and other expenses. Other expenses is could be come from taxes, transport, offices, and other sort of expenses that are not included in this types of tangible inputs. So once again, the Sumanth model, total productivity model by Sumanth, can be calculated by calculating the total tangible output divided by the total tangible inputs. That's the Sumanth model. Okay. All right. The second model that I'm going to talk is Craig-Harris model. Yeah, Craig-Harris model. So Craig-Harris model, also known as service flow model. Service flow model. So the logic is like this: the input are converted into cash, which is the payment for services provided by inputs. And then productivity is viewed as the efficiency of conversion process. Yeah, once again, the input are converted into cash. So every input and then converted into cash into the value of money. And the productivity is viewed as the efficiency of the conversion process, the conversion from input into output. All right. So the simple equation for the Craig-Harris model, you can see on the slide there. So P, or productivity, is output divided by the sum of all the input. The input may consist of L plus C plus R plus R plus S and X. Yeah, where O is the output. Yeah, O is the output, and then L is the labor inputs, C is capital inputs, R is the raw material and parts purchases, X is the miscellaneous goods and services. So once again, O is the output, yeah. And on the previous slide, you can see that all the input are or should be converted into cash, should be converted into the value of money. And the factors of the Craig-Harris model, yeah, may consist of: the first one is the labor input, and then second one is capital input, raw material, and miscellaneous goods and services. Other goods and services that should be paid by the organization or the company in order to produce the output, in order to produce the output. Okay. Could be delivery, could be what is it, electricity, yeah, something like that. And capital can be, what is it, some investment for the machine, investment for the building, the factory, and so those sort of things. So that's the second one, the Craig-Harris productivity model. The third one is what we know as APC model, or American Productivity Center model. The American Productivity Center has measured that express profitability as a product of productivity and price factors. So, according to APC, or American Productivity Center, there is a sort of relation between productivity and profitability. Okay, productivity and profitability, where profitability is a product of productivity and price factors. So productivity times price factors is profitability. So you can see on this equation. So profitability is productivity times price recovery factors. So according to APC, profitability can be calculated by sales divided by its cost. Sales divided by cost, where sales is output quantity times the price, yeah, how many output produced by an organization. It could be what is it, manufacturing organization or services organization. The output could be services, could be finished good. Yeah, when the output quantity times price, yeah, it come up with the sales. So sales is this one, output quantity times sales. And the cost is the input quantity times the unit cost. Input quantity times unit cost. So productivity, according to APC once again, profitability according to APC once again is productivity times price recovery factors. Yeah, if we go back to the general, general calculation or formula for productivity, where productivity is output per its input, the ratio of output and input. So productivity here, yeah, can you see here, is output quantity per its input quantity. And price recovery factors is price per unit cost. Yeah, so if you check the formula here, productivity is input by output by input. So this formula is substituting the formula on the profitability. Yes, the APC model. And the fourth one is Taylor-Davis model. Yeah, Taylor-Davis model propose or develop total factors productivity or TFP. Yeah, so total factors productivity of a firm. Yeah, and the total factor productivity is measured by the formula as the following. So TPF or total factors productivity equal to S plus C plus MP, yeah, minus E. So S is the net sales, yeah. C is the inventory change. MP is manufacturing plan. So net adjusted sales is sales in dollars for a particular period. So sales in dollar for a particular period divided by price deflator, yeah, divided by 100. Yes, so the amount of sales in dollar, yeah, divided by price deflator. So price deflator could be influenced by some factors. For example, the change of price, could be the inflation, something like that. Yeah, so that's price deflator. And C is inventory change. Yeah. MP is manufacturing plan. Yeah. So manufacturing plans may include items that are available outside the firm, but they are produced internally. Yeah. Could be maintenance, machinery, equipment, and R&D or research and development. Okay, that's the TFP. And W and B. So W is the wages or salary, wages and salary. Yeah. Oh, sorry, I forgot the E here. So E is the exclusion, is exclusive material and services that are purchased outside the firm. Material and services that are purchased outside the firm. That's the E. And then we have some notation here like WB, KW, KF, FB, and DF. So W once again is the wages and salary. B is the benefit. Benefit is every kind of benefit that received by the company. It could be vacation, it could be a leave, insurance, sickness, social security, retirement, profit sharing, and something like that. Every benefit that are received by the company or who is it? The employees. That's benefit. So if you work in a particular company and they pay your insurance, for example, that's a kind of benefit. If we work in a particular company and then they cover our healthcare costs. So for example, if we are sick, if an employee is sick, or they have to hospitalize, something like that, and parts of the bill or maybe all of the bill are paid by the organization, that's example of benefits. Okay. Another example, if the organization provide transportation facility, yeah, give some of the employee a car, for example, or motorcycle, yeah, that's another example of benefits. Okay, social security, retirement, yeah, in some place in Australia, if we hire people, we have to pay what they call as super. So super is kind of contribution from the organization in order for the retirement of the employees. That's benefit. And then KW is working capital. Working capital. Working capital may include cash and notes, account receivable. Yeah, account receivable is like invoice that received from the vendor or from the supplier, yeah, as well as inventories, prepaid expenses, and something like that. So all is the example of working capital. And then where KF is fixed capital, yeah, it may include land, buildings, machinery and equipments, as well as deferred charge. Yeah. FB is investor contribution in percent, and DF is price deflator, is also could be in percent. So this is the total factors productivity, or total productivity by Taylor Davis. Yeah, sales plus inventory change plus manufacturing plant, yeah, minus the E. E is the exclusion. Okay. W is the wages and salaries. B is the benefit for the employees. KW is working capital. KF is fixed capital. Yeah, times FB. FB is the contribution from the investor, and DF is deflated. Or in other words, we can say that the total factors productivity is the total value minus the added output divided by total input. Total input could be consists of all the capital and the labor. That's number 4. So remember, yeah, model number 4 by Taylor Davis. All right, now we're going to the next model, yeah, what people usually call as objective matrix, or OMAX. So OMAX is a bit different with the other productivity model, yeah. Other productivity model like Craig Harris or what's the model before this one, Taylor Davis and Sumanth, yeah. Most of them, they calculate the total productivity or total factors productivity. But OMAX is, in my perspective, only a model to calculate partial productivity. So OMAX is a partial productivity measurement, yeah, and is developed for controlling productivity in each part of the firm system based on criteria of productivity. So if we want to evaluate the performance of each part of the organization, of each part of the company, yeah, we can use OMAX or objective metrics. Okay. And OMAX itself, or OMAX method, firstly developed by James L. Riggs from the Department of Industrial Engineering at Oregon State University back in 1980s. Okay, the appearance of OMAX pretty much like what you see on your slide now. Yeah, there are three main parts of OMAX. The first one is A part. So A part is the definition block. Yeah, definition block, and then the B part is quantification block. Yeah, quantification block, and the C part is weigh and value block. So definition block, it may consist the criteria for productivity measurement. In which part of the system, yeah, if you see there, here, sorry, which part of the firm, of the organization that will be calculated, yeah, that will be calculated. So in the A part, yeah, may consist of the criteria, productivity criteria that we're going to calculate. Yeah, in this case is the part of the organization or the firm that we're going to calculate the productivity. That's for the A part. And the B part is the quantification block. Yeah, quantification block meaning that we're going to feel the value. Yeah, we're going to feel the value for its score here. You can see on the your right hand side, there is score from 0 to 10. Yeah, and we need to feel the value associated with this score. I will give you example later. All right, and the C part is the weigh and value block. The weigh and value block. Yeah. So each productivity criteria in definition block or in A part will be put the way for each criteria as well as the value. Yeah, that's those are A, B, and C. All right, and then like I mentioned that on the top of the OMAX model is the productivity criteria. Yeah, productivity is criteria. And then another part of the A part is the measured performance. Measured performance is the result of the measurement of performance in a particular period. The result of performance measurement in a particular period. Yeah, it could be weekly, it could be monthly, it could be yearly. Yeah, for each productivity criteria. Yeah, that's what we need to feel on the A part. On the B part, yeah, mostly is talk about the or mostly consists of the score. Yeah, from the worst performance to the expected performance and the base performance. Worst performance will be scored 0, expected performance will be scored 10, and the best performance, yeah, all best performance will be scored 3. All right, all best performance will be scored 3. All best performance, and the score itself is ranging from 0 to 10. Ranging from 0 to 10. That's from the quantification block. On the value, yeah, on the value, it consists of at least 3 main parts. The first one is the score. Yeah. So what we're going to do is we fill the value here, yeah, on the quantification block, yeah, and then we're going to see in a particular value what are the associated score. For example, in here, yeah, associated score is 8, so 8 will be filled in the scores here. And way is the way for is productivity criteria, yeah, the way for is productivity criteria, and the value or productivity indicator is the sum of the score for its criteria times the way, yeah. So the example is like this, yeah, this is the example. So in a particular organization, they're going to calculate or measure 6 productivity criteria from speed of services, and then lateness, queuing, idle time, absent, and complaint. Each productivity criteria has its units of measurement. For example, the speed of services, the unit measurement is minute per man. So speed of services is minute per man, means that every employee there, the speed of services should reach a particular minute. Yeah, this unit of services. And from the what is it? From the observation, yeah, in January 2003, for example, the worst performance of speed of services is 10. So this is the worst performance, and the expected performance is 2. Yeah, so means that if the speed of service, the number of the value of the speed of services is lower, it will be better. Yeah, because the what is it? The measurement, the measurement is minute per man. So to accomplish or to serve one person, how much minute that they need? Yeah, so shorter the period of services, it will be better. It doesn't mean that even the name is speed, but we have to consider the unit of measurement. Okay, and then the best performance is 4. Yeah, so the expected is 2, the worst is 10, the best performance is 4. Okay, and then on the 30th of December, I will double check on that one. Yeah, I will double check on this date. Yeah, maybe there is slightly a hiccup that one. So it's 30 December 2003. It could be almost a year after 1 January 2003. Yeah, almost a year. Yeah, but I'll double check on that one. But most importantly is this is the measured performance. The measured performance on a particular what is it? On particular periods. Yeah, it could be on the 30th of January, maybe not 30th of December. And the measured performance is 3, and the best performance is 4. Okay, let's see how we put this one into the objective matrix. Okay, please check here. Apologize, still in bahasa ya. Here is the speed of services, yeah, and you see on the performance row the score is 3. On the performance row the score is 3, so it comes from this one. Yeah, comes from this one. The measured performance is 3. And then can you please check on the number of the expected performance, worst performance, and best performance. So expected performance, worst performance, and best performance. Yeah, expected performance should be scored the lowest, which is 0. Sorry, expected performance should be scored the highest, which is 10. And the worst should be scored in the lowest, which is 0. And the best performance should be scored 3. Okay. So here, the best performance is 2, yeah, and the score is 10. Okay. And the worst performance is 10 and the score is 0. And the best performance is 4 and the score is 3. All right. And what about the other row? How should we fill it? So you just need to divide it evenly for its level of score. Okay. So for example, here is from 4 to 2, yeah, 4 minus 2 divided by how many level? Maybe divided by 7, yeah, and then you distribute the result evenly to each row, as well as from the best performance from 3, yeah, from score 3 to score 0, yeah, 3 to 0, yeah. So 10 divided by 10 minus 4 first, which is 6. 6 divided by 3. So there are 2 in is plus 2 in each step, in its level of score. So from 4, and then in the score 3, in the score 2 is 6, in the score 1 is 8, in the score 0 is 10. All right. And this calculation also applied to other productivity criteria. Let's get another example. Yeah. All right. So please check on the, maybe we find the easy score. All right. On the productivity criteria number 2, which is lateness. So expected performance is 10. Yeah. And then the worst performance is 60, and then best performance is 45. So expected performance 10 will be scored 10. Yeah, yeah. Best performance will be scored 10. And then worst performance, which is 60, will be scored 0. And the expected performance 45 will be scored by 3. And the rest will be divided evenly for each each row. All right. And then please remember also that the performance measured here, it will be added into the performance row in here. Yeah, performance row in there. All right. So then how we calculate the OMAX? How we calculate the value of productivity index? All right. So what we're going to do is we need to determine the score for its performance here. Yeah. For example, after we fulfill all the metrics here, yeah, after we fulfill all the metrics, we need to find out the performance, how much the score of the performance. So, for example, on the speed of services, yeah, the result of the measurement is 3, and we need to find out in this column what number is the closest to 3, and we find this one, 3.16, and 3.16, the score is 6. If the score is 6, and then the score will be added into here, into the score. And productivity criteria number 2, yeah, the lateness, the result of the measurement is 30. So 30 is pretty much here, exactly. And the score is also 6. So the 6 is added here. And then the length of the QE, yeah, the measurement, the result of measurement is 5. And then we need to see in this column which cell is closest to 5. So we have here 5. And the score is 3, right? And we put 3 there. And so and so. All right. And then the next step, after we calculate all the score, or after we determine all the score, what we need to do is we multiply the score by its weight. So 6 times 20. Oh, sorry. So this one is 6 times 20. Yeah. This one is 6 times 30 into 180. 3 times 10, yeah, 30. 2 times 15, also 30. 2 times 15, 30. And 7 times 10, 70. And then we add them up to 460. So 460 is the performance indicator for the current period, and the previous is 300. Yeah, the previous is what we have calculated from the previous period. So the index is 53 times 33. So this is the formula. So index of performance is productivity indicator on the measure period minus the base performance, yeah, and the value is 300, yeah, divided by the base performance. So from the calculation, we have 460 minus 300 divided by 300. So it's pretty much times 100%. So 553.33. So if the index performance is more than 0, it means that there is the index is good. All right, and then the last model that I want to introduce to you is the model of Marvin Mondo. The model of Marvin Mondo. Okay, in Marvin Mondo, there are some equation. The first one is what usually called as PI, or productivity index. Yes, PI is AOMP by AIMP divided by AOBP per AIBP. So what is AO? AO is actually aggregate output, and AI is aggregate input. AO is aggregate output, AI is aggregate input. MP is actually measure period, BP is base period. Yeah. So productivity index is in the Marvin Mondo is pretty much productivity index in the measure period divided by productivity index on the base period. Or in other words, we can say that the current performance index, or PI, or productivity index, yeah, current performance index by its base performance index. Ratio of the current to its base performance index times 100. All right, so this is the what is it? Productivity or performance index, yeah, or output index, yeah, per its input index times 100. So this is what is AOMP, aggregate output measure period, AOBP, aggregate output base period, as well as AIMP and AIBP. So that's the some formula that you need to know. So the Marvin model also measure total productivity. So it's similar with the other model, but a bit different with the OMAX. So OMAX is for calculating the partial or a particular criteria of productivity. So once again, Marvin model is measure total productivity, and it will be done by comparing between productivity in measured period and base period. So index of productivity in base period is 100. So there are three steps of index of productivity in measured period. So if the productivity index of the base, we presume is the value is is 100, for example. So if index of productivity less than 10, It means that the productivity in measured period less than the base period. Yeah, if the productivity index is less than 100. Okay, if the productivity index equal to 100, it means that the productivity in measured period equals to productivity index on the base period. Right? And then if the productivity index is more than 100, yeah, it means that the productivity is measured in the measured period better or more than the base period. Okay, so the better productivity, the higher the IP. So if the IP is higher, means that the productivity is better. And the IP is always more than 100. Okay, this is the example of calculation of Marvin Mondo. Yeah, in airline company. Yeah, if you see there are two different years from 2008. Sorry, in the year 2008 and 2009, and we have several information from the statement. Yeah. Number one, we have the ticketing. Yeah. In 2008, the company has approximately 10 billion, and 2009 is 15 billion. Yeah. Direct labor cost 4 billion, and then improved to 5 billion a year later. Yeah. We also have the information for indirect costs, cargo service, overhead costs, VIP flight service, building cost for rent, maintenance cost, and administration costs. Now, the question is, please determine the AOMP, AOBP, AIMP, AIBP, CPI, BPI, OI, II, and IP. So we will calculate it one by one. Yeah. First is the statement of output. We need to determine which part or which statement are the outputs and which statements are the input. So the output can come from the ticketing, and then the cargo services, and VIP flight services. And the input, I mean, is the direct labor cost, indirect labor cost, overhead cost, building cost for rent, maintenance cost, and administration cost. Those are the output as well as the input. All right, and then we need to calculate that one. So the AOMP, aggregate output on the measured period. So measured period is meaning that we need to calculate in the 2009, because there are two different years, 2008 and 2009. So on the measured period, yeah, aggregate output is the output for the value, the sum of the value for the output. Yeah, that may consist of cargo and then ticketing as well as the flight services. So three different factors. Yeah, so 15, 1.4, and 0.6 in billion. So 17 billion is the AOMP, AOBP is 12.5 billion. And then the aggregate input for the measured period is 11.5. Aggregate input for the base period is 9.5. And then BPI, yeah, BPI, base performance index, yeah, or productivity on a particular base performance or base period. Yeah. Yeah. So output by its input, the ratio of output by input in the base period is 12.5. Yeah, came from here, and 9.5 is from here. So 1.32 from the base performance index. And the CPI is the current performance index, is on the measured period. Yeah. 17 is from the AOBP, AOMP from the measured period. 11.5 is the aggregate input for the measured period. So this current performance index. OI is the index of the output. Yeah? Index of the output is output for the measured period divided by output for the base period. Yeah, it's 1.38. And II is input index. Yeah? Input on the measured period divided by input of the base period is 1.2. And the productivity index productivity index in 2009, yeah, you can see here, yeah, is 112 times 35, so which is good, and there is an improvement on the productivity index. All right, I think that's all for today. Yeah. Okay, that's all for today, and thank you very much. See you again on the next meeting. Assalamualaikum warahmatullahi wabarakatuh.